Why does this matter in pharma? That's perfect.
Great. Okay, great. So,
Daniel, if you don't mind, you might just put the main slide back up and just move forward, and then we'll just start the recording from there if you want.
Okay, we can also do that.
Oh, you can. Don't do it. Or if you can. There you go. That's perfect.
We can do it.
Perfect. Right there. There you go. It looks great.
So you want to start recording?
Yeah, it's starting right now. Oh, you're good.
Okay, great. So yeah, so welcome to this workshop where we will be looking at how you can come from a statistical method that you maybe find in a paper or that some of your colleagues came up with, and how you basically engineer an R package from that implements this method, that your team can use it, other statisticians can use it. You can publish this, and we will be looking at a specific example of the mmrm package. And I'm here together with Doug Kelkhoff, also from Roche, and we're very excited to do this today. We will cover really practical steps for going from the statistical method to the R package, with some key considerations, and illustrate with mmrm example. And in the second hour, we will also look at the hands-on demo for the mmrm R package. So we will do that on the POSIT Cloud, and also discuss some aspects of how we work together across different companies and in open source, and how we made it work. Slides are available at tinyurl.com/mmrm-workshop-slides if you want to follow along with that. And we will start off with some key considerations for writing statistical R packages. Why does this even matter, specifically in pharma? We're going to have a quote here from the kind of Bible of for statisticians. That's the ACH E9 guideline. And in particular, there we have a section on integrity of data and computer software validity. And what does this say? It says the credibility of the numerical results of the analysis depends on the quality and validity of both the methods and the software that is used for data management, but also for processing the data statistically. So the computer software used for data management and statistical analysis should be reliable, and documentation of appropriate software testing procedures should be available. Right, so that's basically telling us we need to do something here. We need to be careful. And Doug will.
Yeah, so as Daniel mentioned, we're going to kind of ping pong this presentation a little bit. So I'm hopping in to kind of cover a few of the high level principles that are guiding the open sets where development process, and specifically the development of mmrm. So when we're thinking about how we want to achieve statistical method implementation, there's two kind of key things that we really are valuing, and that's to make sure that the software is reliable, and we achieve that through appropriate testing. And this assures this high quality and validity that we're aiming to achieve. And ultimately, back to the guidance that we just read off, this is helping us to achieve this credibility of our statistical results. So we're going to cover now, we're going to have a little section here where we're covering these four different like guiding principles of this statistical software development process. And what we're going to cover here is how we choose the right methods, and more importantly, understand them, how we solve these core implementation problems by going through this prototyping process, how we incorporate the design of a package into its development process, and the assumptions we make about the life cycle that we expect a package to follow, and how we incorporate that explicitly into the development the development path that we are taking. So next, when we're talking specifically about choosing the right methods, there's a few things that we think are really important. So back to this guidance, I'll just read this critical sentence again. The credibility of the numerical results of the analysis depends on the quality and the validity of the methods and software. So fundamentally, this is a key part of any regulatory software, and we take that to heart. So one of the things that we can do is really focus on making sure that we're choosing the right method. And not necessarily just like the method that implements the thing that you're looking for, but specifically, does it implement it for your purposes? And does the implementation also then lend itself to the credibility of your statistical analysis? And we do this also by partnering with methods experts. So that can be internal, external. It can be people that have worked on this type of method in the past, academics, or other people that have developed similar software. And then also thinking about how do we understand the statistical methods themselves. So it's not just sufficient to copy and paste code, we also need to make sure that we kind of internalize that code or that method and make sure that we're applying it correctly. So we specifically will reach out to experts and ask them to summarize these methods. What always helps is reading the summarizing papers that these things are distilled into, trying to paraphrase that, make sure that your understanding of it is in line with what these experts are trying to communicate, and then making sure that when you do go back to the implementation, that these the details of the original paper are kind of reflected in the implementation of the method. And so the way this is going to work for the next few sets of slides is that I'm going to cover the kind of the general themes, and then we're going to hand over to Daniel to talk about how that's been implemented in mmrm. So over to you.
Okay, great. Thanks, Doug. Yeah, so how did we do that with mmrm example? I mean, first of all, we need to understand the acronym. It's not that difficult, but it's called mixed model with repeated measures. In terms of understanding the method, it's already a weird name because it's actually not a mixed model, as we typically understand it in statistics, but it's just a general linear model. So basically a linear model where we have correlation assumed between observations of the same kind of individuals. And the most important thing was to read an overview paper first, to basically understand this part. What is this really doing, this mmrm? What's the general linear model behind? And then for understanding the problem, in R, we did not get the correct adjusted degrees of freedom with the existing packages. That was really the main problem that we hit when we wanted to implement mmrm in R. Of course, we tried out existing packages and compared the results with proprietary software, and we saw that there's differences. And we really read the paper describing the adjusted degrees of freedom to really understand, okay, what is actually the thing that we want to calculate here. So that was kind of the beginning. And then, yeah, fast forward, 2 years or so, we had an initial implementation actually that used the LME4 R package as a kind of workaround. So, and actually I presented on this, I think 3 years ago, at our pharma as well. You can have a look at that. That works only quite okay, unfortunately, as we found out then later for small data sets with relatively few time points. But unfortunately, it does not converge, and it can take hours on large data sets, nevertheless, that have many time points. So it was a little bit then frustrating to see that actually it fails on those things. And when colleagues then came to me with specific data sets that really took hours to run and then it didn't converge, then I knew, okay, we needed to look for another solution, another implementation of this method.
All right, so back over to kind of the general principles. The next thing that we want to make sure that we're addressing is that we're properly prototyping the solution. And Daniel already kind of alluded to this with implementation in LME4. And so I'll just kind of like double down on how this might look and how we can embed this into our practices. So prototypes come in many different forms. It doesn't necessarily need to be a package. It doesn't need to be as rigorously documented because probably it's changing very dynamically. It doesn't necessarily need to be unit tested, although it can certainly kind of help to make sure that you're developing in the right direction. Some solutions that worked really nicely for us would be using an R Markdown document or a Quarto document. And that's a good way of just kind of annotating the work that you're doing. And this can be an R script also coming from the methods experts themselves that implements these methods. And you can slowly kind of reshape that into something that resembles more of a reusable piece of software. So often this is usually how, especially internally, we'll start receiving kind of this type of feedback from analytic workflows that might have already embedded themselves in the business. We can then also kind of translate those into internal products at Roche or other kind of open source projects that we want to instill as more reusable software. So how do we know when we've actually solved this core implementation problem? So it's not always like a definitive milestone that you always hit, but it definitely helps if you've properly calculated results that are reproducible, maybe from publications that already show what some kind of reference implementation would produce. Different methods, options have been explored, and you've kind of considered why you might choose one or the other. You've possibly evaluated different solution paths. So Daniel mentioned doing an implementation with LME4. That also can kind of like feed itself into the weighing the different options, the different software backends that you might use, or the styles that you might use to represent this idea. What I always find helpful is kind of distilling what you think will be the bottleneck for implementation, trying to find what you see as this like central hardest challenge that you would have to overcome during development. And if you know that you can solve that, then maybe you have a better idea of how everything else comes together. So then it's, hopefully you have a better idea of how the rest of the pieces will fit. And if possible, like I mentioned, you've maybe compared this against a reference implementation and you have some good consistency with the results that they were producing. All right, back to you, Daniel.
Thanks, Doug. Yeah, so how did this work in mmrm? Again, we first tried to use the existing packages, and that's of course the first thing you should do, right? You should not directly start to write things from scratch for your problem. So the hardest part again was to get the degrees of freedom adjustment correctly calculated. And we actually tried different solutions. So we tried to use the recommended or even base package, I forgot what it is, NLME, with EM means, right? That's a contributed package. Unfortunately, the results were too different here from the reference implementations, and calculation was basically too approximate. As mentioned, we used LME4 together with LMER test. Those are great packages, but unfortunately for our use case, that failed on large data sets with many time points, as already mentioned. And then we looked into GLIM TMB, which is also a great package, generalized linear mixed models, but unfortunately it didn't have the adjusted degrees of freedom. So that didn't work. Next off, you can try to extend existing packages, and that's also, of course, great to try first, because we don't want to increase just the number of packages infinitely on cron, but we want to kind of have meaningful kind of package convergences that try to include the features we need. So we actually got in touch with the GLIM TMB authors, in particular Ben Walker, provided great help and assistance. Tried this out. Unfortunately, it didn't work out. Results were very far off especially for the unstructured covariance MMM. And we then understood that GLIM-TB always uses a random effects model representation, which is not what we want in our case. We just want to have fixed effects with a structured covariance model. So next was then the last thing to try to make a custom implementation ourselves. And the idea was now to use the template model builder, short TMB library or package directly. So that's, as the name suggests, TMB is actually also used by GLIM TMB as the backend for the calculations. And the cool thing with the TMB package is that we can code in C++ the likelihood of the model we exactly need, right? So again, that's a general linear model without random effects, just with a structured covariance matrix. And the magic of TMB is that it allows to automatically differentiate the log likelihood with regards to the parameters, right? And it does that by compiling the C++ code, and then basically from that automatically deriving the differentials. And those differentials, so the gradient and even the Hessian, if we want, we can use them then from the R side to find the maximum likelihood or restricted maximum likelihood estimates of the model parameters pretty quickly and pretty efficiently. And I was then fortunate that within a long weekend where I think it was actually the first time I had COVID, and I was anyway locked up at home in my room. So I had time, and I got a working prototype that was fast and matched the proprietary software results pretty nicely. And then I knew, okay, this can be a viable path.
Cool. And then the next principle that we're going to cover is how to approach the design of an R package. So the design is always a critical part of how you plan to structure things, because it's always how your ideas manifest as programming concepts that then play or don't play nicely with other tools. And so the better that you can integrate with the existing ecosystem, the better the adoption and the sustainability of your R package. So we'll talk about a few considerations that help with that aspect of things. The important thing first is not to immediately jump into writing a bunch of code, which can be very tempting sometimes. It's important to kind of take that initial step back and make sure that you're seeing the bigger picture of how everything is intended to fit together. And by this, we mean try to make a more kind of concerted articulation of what the scope of the package should be. And this often means carving some things out, saying explicitly what the package shouldn't be, because keeping a very specific scope will also make the intention behind the package a little bit more clear. It usually helps to make it feel a little more cohesive. And then there can always, those other things that are deemed out of scope can maybe be extensions or other packages themselves. And specifically, it's also good to get rapid feedback about this this bigger picture, and that can be experts and users that just the same regarding workflows that they intend to use it in, or other ways maybe that the model needs to be extended if this is more like expert feedback, just to make sure that those things are incorporated into the design process. When starting to write the functions, it's good to start doing this together with documentation and unit tests, especially if you have a good design doc up front. Then you kind of know these things are going to be a little longer lived. You know that that time invested in writing this documentation unit test is not something that's only for this prototyping process, but is going to be sustained throughout the rest of the development. And what that means is, especially if you're working with other people, you're staying aligned throughout the development process. And this means that as you're going along, you're communicating to other people what the intentions are of these little pieces within the package. How might you go about this design process? Just drawing a simple flowchart can be a really helpful tool. This can be something you just scratch down on a piece of paper. Starting to break things down into functions and classes is really nice. Once you get a little more, mature in that process, you can maybe try to do this using a digital tool that helps to kind of like share it with other people. It really helps to start drafting these things into a design document. So you can start really breaking down what are these things like the components of different classes. How are you going to organize your data? How does that flow from one function to another? How is it reused by later functions, or where is it needed? All of that stuff can be really helpful for just structuring the general analytic flow of what a package is designed for. And then as you have that, if you already have this design implementation, something like an R Markdown document, you can start kind of reworking that, retooling it a little bit using these ideas, just to make sure that they kind of map nicely into this structure that you're planning for. Once you have that, you can start breaking these down into specific tasks, and you can start kind of working through the dependencies of those particular things. So you're starting from the most central components of your project and working your way outward to kind of layer on these additional pieces of complexity to really represent your workflow.
Yep. And how did this look in the mmrm example? So I don't have the scratches on paper now that I had initially, but at least I want to show you here a little bit the single markdown document that we had as initial design document that included the prototypes. So this is really one of the first things, and just browsing through here, just want to illustrate that I had here thoughts, right? So what do we want to do? We're talking about some objectives. We're talking about some data example. Then we're talking about prototype code, as mentioned by Doug. We basically want to have some prototype code here. Let's quickly try the functions out. Does it work? More or less, etc. And then it goes on and on and on, right? We talk about building the model formula. How could that look like? The function for that. And so on, right? So it really goes on and on quite long here. But the important thing is that I worked through this kind of model fit one time in this prototype in this design document with the prototype code, so that I knew that it really kind of works. And I also then know which kind of pieces do I need, right? So I have all of these little subsections here on these little helper functions or main functions that are part of the user interface, and then I can organize this now into tasks pretty nicely as a next step. So let's look at to the next step. So the next step is then really to go, for example, into GitHub or GitLab, and start writing down those issues that you have for your pieces. So I would recommend really having one issue for each kind of function, for example, or each kind of class if you have a more class-based package, because then you can really kind of even distribute this to a team if you have multiple people, or even if you're just alone in the beginning. It can be super helpful, because then you can still switch back to other kind of work when you are not having time for this package implementation, and you're going to continue easily later because you know exactly exactly what issue is next and where you are with that, right?
All right, jumping into the next principle. So the next kind of philosophy that we try to follow is that this idea that an R package is intended to evolve for a long time. So if you're like me and you've done some analysis in the past, and you might have built a package to support that analysis, there's kind of this different feeling when you're building a package that really is just like a way to tuck functions away into a cleaner, safer keeping. But there's not really this intention for it to grow any further beyond that analysis. Versus when you're making a package and you really intend for it to be something that is sustained. So that if you've encountered that, you probably are familiar with this feeling. If that's something that is new to you, just suffice it to say that can look very different in terms of implementation. So particularly when we're thinking about evolution, one of the things that we are really mindful about is documenting the statistical methods that we plan to implement. And so what this can look like is something like a vignette often, where you kind of work through maybe some core workflows that are specific to that particular methodology. And this can kind of serve as this glue between the source material, the statistical representation, the academic, mathematical representation of what this model should be doing versus the implementation in the code. So mapping those two things from one to another is the process of building the package, but as also for your users, the process of adapting maybe their understanding of the method into their use of a tool. So what this can mean often is adapting a lot of the terminology, the mathematical representations that might have been used in the original paper over to corresponding terminology that fits more nicely within the use of the package, since those aren't necessarily always the same thing. And then also diving into the specifics of how that gets represented in software, which might have its own caveats or concerns that you need to address. What this means is that users benefit from having this method documentation because hopefully it makes it a lot easier to understand what's going on. And if they're coming already with an understanding of the method itself, then mapping that knowledge into the use of the software is something that's a little bit easier of a bridge to manage. Also, developers kind of benefit equally in that they also need to continue to see how other people have looked at this problem and how other people have adapted mathematical ideas into software ideas so that they can stay up to date on what the considerations are in terms of further improving those methods. Another way that we maintain sustainability in tools is by always incorporating testing. So almost certainly, 100% guaranteed, there are new features that are going to come after you release a piece of software. So one thing you can do already is kind of release early because you can assume that this is going to come eventually. At least you're getting an exposure to those ideas as you still might have time to internalize them into the development process. But more importantly, it means that people are enthusiastic about what you're doing. And it means that there's other ways that people are looking at the problem and how it fits into their analysis that you might not have even thought of. And so it's in that sense, it's very likely that the needs of the package might change over time. And that means incorporating maybe new workflows or new features, maybe adapting it into new analysis method or analysis workflows. And that means that kind of the intentions behind the package might evolve. And if you need to evolve the package to adapt to those changes, then it's very helpful to have testing that makes sure that you're not breaking things along the way. So including things like integration tests to make sure if it needs to talk to other software or other analysis tools, that it is continuing to work nicely with those. But then also making sure that if you have a reference implementation with known results, then you're at least comparing to those to make sure that those continue to stay correct. And as you're changing the package, you know that having this assurance that these tests are continuing to work kind of gives you this sense of confidence that you're able to tweak things without necessarily having to constantly revisit just the underlying assumptions of your software development practices. So just some on the software side, thinking about now how we actually make a package extensible, and maybe taking a step back to talk about what extensibility actually means. It often means that others can then extend the package or make use of the package in contexts that you might not have initially intended. That also means that we as developers might want to then incorporate those features back into the package. And that's another form of extensibility, is kind of like that internalization of these other needs. When you know a package is extensible, that means that others can extend it easily. That means integration with their own tools or their own processes. And some guidances that we have in terms of how you might achieve this is to make your internal functionality composable. So instead of having long, functions that do a ton of different things, they might have many arguments that are kind of like their own little sub-analyses that can be conducted in a larger function. Instead of trying to do it that way, how do we make those things individual components, similar to kind of like the tidyverse? If you do like data analysis or plotting, you kind of build larger constructs from smaller pieces. That same concept applies in statistical software. One particular design that's been rather fruitful in the OpenStatsware cohort of packages is this object-oriented philosophy. That's something that can definitely help if that's a paradigm that you're very comfortable with. Structuring it in that way can make it much easier to kind of like contain that complexity of organizing a bunch of data structures. All right, so let's see what this looks like in mmrm.
Great, thanks, Doug. Yeah, so in mmrm, the method documentation, again, very important. Basically, it started again with some handwritten notes of the algorithm that actually implements the prototype. Really kind of how is this log likelihood calculated for this mmrm? How is it different if we have a restricted maximum likelihood estimation, because then we basically need to integrate out basically the fixed effects parameters first, right? So we only left with the covariance parameters. And then I translated that into a vignette pretty early on, and it has been updated now many times already because the algorithm was updated a couple of times with new features, things like group-specific covariance estimates, things like spatial kind of covariance structures and those kinds of things, right? So also weights, for example, we will have a look later at that in the demo. So meanwhile, we have already total 12 different vignettes in the package on different aspects. They're not all on the methodology, but some of them are. And that's really super important, again, as mentioned, both for us as developers, to later go back to this and have a high-level introduction, especially when you come new into the package, but also for the users, that they really understand, okay, what's exactly implemented here without kind of trying to decipher the code themselves. But getting a high-level summary from these vignettes is super helpful, and also to see kind of how it actually works, right? And maybe if they're new to the methodology, they can also look at these method vignettes and really understand the methodology. So here's a little, just a little screen showing the model fitting algorithm vignette. And you see here that we define the model. We have some mathematical notation here, not too much. And of course, you will not find any proofs here or something. But we definitely define a linear model. And we talk about the covariance model as well. And there's different options, as you see here. And then we talk about the maximum likelihood estimation, right? How is the likelihood looking like? And those things you can then find as a developer. You can go back to the code base and really can see those things represented on the C++ side in the TMB framework, how we actually calculate this in the package, right? So that's important. And in terms of the tests, also again, super important to keep this surviving this package for a long time and really kind of sustainable, that we can add new features with confidence, or we can refactor also pieces with confidence. And that also has happened already a couple of times now, even though the package is just 1 year old. So it's important that we always add the tests and the documentation, both for the code and for the method during each pull request when we update this on GitHub for each function or class that we're updating. And in particular here, it's also important, and probably for many statistical packages, that we have integration tests comparing really the final numerical results with the numbers we can source from somewhere else, for example, from proprietary software, or from another R package implementation that is relatively close, but maybe not exactly the same. Some tests can also sometimes take a bit longer to run if that becomes an issue. For example, when you do your cron submission, you can also skip them on cron. There's this little skip on cron functionality in the test.dat package that makes that easy. Turn out the tests were really super important here in particular. If you have this compiled code in your package, because I had a case where I had some minor C++ changes, but that could break results on different operating systems completely. The code was still running, but it was just producing bogus results. So then I needed to go back and revert those changes, and it worked again. And that I wouldn't have seen at all if I just would have relied on examples are running and stuff like that. I wouldn't have seen that. Regarding extensibility, that's not, let's say, a big topic maybe as such here for the mmrm package, because mmrm is a typical model fitting package. Therefore, we only use the standard simple S3 class system that's available in R. The good thing still is that we define mmrm S3 class, so that over time people can add interfaces to other modeling packages, and we will see that later a little bit more in detail how that looks like. Great. So that was kind of the first part, the key consideration. So here I would like to make a pause and see if there's any questions from the participants.
Let's take a quick look here.
Thanks.
So let's try this one here. When you compare results to commercial software, how do you arrive at acceptable difference, and how to explore different sources contributing to that error? Does that help?
Yeah, that's a good question. So that's a great question. And I don't think there's like a unique answer to this. So in the mmrm package, we use, for example, like a relative difference as a kind of comparison. And we want to have a relative difference that's smaller than like 0.1%. So that's like 10 to the minus 3. And that's kind of the standard default tolerance that we have for these kind of integration tests comparing with other software results. And you might see that maybe for some options, maybe you have, for example, a compound symmetry covariance model. Maybe you see a little bit larger, maybe 10 to the minus 2 relative differences compared to other covariance models, which seem to match much more closely. As long as, I would say, as long as those differences are kind of still remaining small, and again, what small means, that might depend on your application and on your methodology, but they are kind of consistently small in the same range, when they are not kind of wildly fluctuating between very large and very small, then I would be not so much concerned, and it should be okay. How to explore then the reason for these differences, then it gets already much more difficult, especially if you're comparing with closed source software, so where you can, for example, not dig into the code yourself and maybe find differences in the actual algorithm, right? Of course, it's easier if you, for example, compare with another R package, where you could have the open source code available, and you can dive into those code details, and maybe you can find differences in the algorithm. But typically, we need to stay on the surface there and look at the documentation. What, for example, does the proprietary software say about its algorithm? Do they mention maybe anything that looks different to what you have in your algorithm? Right, and we have a couple of places in the mmrm package, for example, the Kenwood-Roger implementation, where we do have some differences. That is just due to a different parameterization of the covariance model, and we try then to transparently describe those differences also in the relevant vignettes, so that people that are coming back and forth, or maybe they're coming from the proprietary software in the first place and they switch over to the mmrm package, at least that they are made aware of these differences. Yeah.
All right. A few more. So the second one here says, Daniel, can you recommend a statistics book that links stats to R, but from the perspective of a statistician who creates packages, not from the perspective of methods consumer? Anything jump out to you?
That's a difficult question. That's a difficult question. I'm not sure if this already exists. Maybe we should start writing such a book. Because at least I'm not aware of a book that is especially looking at this kind of intersection. All right, there's a couple of books, of course, that introduce statistical methodology, and then have our illustration for this, and might also be different. And if you look more into Python or Julia, there's also books like that. And that can maybe be a good starting point, but I don't think there is something like that yet.
Maybe if
As
I
far
can
as
add,
maybe Doug knows something.
maybe I'll add one small thing. So our open sci group has a really nice set of guidelines for writing statistical software. It's not necessarily a book. It's more, it kind of assumes that you've done a lot of the development process and are familiar with it. But then it at least sets some bounds on what that development process looks like, specifically pertaining to statistical software. So then maybe you can just lean on any number of books that just cover kind of the standard development practices for our packages, but then supplement it with these considerations.
So I think I added that, Doug, to the chat box. You might just take a double check over it
Okay.
and make sure it's the
Yeah,
right one.
I'll get logged in over here also. So yeah.
Okay. It's a devguide.ropensci.org book.
Oh yeah, perfect. Then that's exactly what I was talking about.
Awesome. So 2 other quick questions, Daniel, and then we'll move on here. One is, one of my main issues when building a package is doing the unit tests. How do you tackle that part?
Probably we would need to talk a bit more. What are the difficulties with that? Typically, it comes back to like a good habit that you kind of just get into the mood of always having the test directly with your functions as you write a function, right? So I would highly recommend to really always do that together. So when you write your function ABC, just directly do the test for your ABC function. Don't think, oh, I can just write a test all later at some point. That's going to be much more painful. And especially you might have maybe some problems with some of these functions that you haven't seen when you wrote them first, and then you might go back and forth later quite often. So I would just say get into the habit of actually doing it right away with the function implementation, and that usually helps a lot.
Yeah, specifically for statistical software, I'd also add that I think there's often a tendency for people to try to pull like real world or like relevant public data sets and just fit the model and make sure that you got the same result. And I think that can be a good kind of like comprehensive test, but that definitely shouldn't make up your core testing strategy. Typically, I think it's better to try to simulate data that articulates different edge cases. And hopefully those are fairly small data sets. So you don't need to be stress testing the performance of a package in your testing suite. What you can do is you can simulate data that's maybe non-normal in a particular variable or bimodal and some weird edge cases that might cause the model to behave differently. And you can test it kind of for statistical robustness that way without necessarily leaning on, especially in the pharmaceutical space, patient data that would be difficult to ship with the package. So that's its own art of simulating good testing cases, but I think that's a better strategy overall.
And Daniel, Doug, one last question here. We'll move on. Is it standard to use TMB instead of Roxygen 2?
Oh, maybe there was some confusion. Maybe I didn't explain correctly. So TMB is not an alternative to Roxygen 2. So Roxygen 2, and most of you will probably have used this already or know about this. That's basically how to produce function documentation or data documentation, any kind of, let's say, object documentation efficiently for R packages, instead of writing directly the RD files in the man folder. That's something I did maybe 15 years ago myself manually. That's a huge pain. So you definitely want to use Roxygen 2 all the time. And TMB is something completely different, right? So TMB, Template Model Builder, that's an R package that's basically wrapping specific C++ libraries to basically allow you to have automatic differentiation for these kind of maybe a little bit more complicated likelihood functions for a little bit more complex statistical models. And that's basically has an interface then to R, right? So it's something completely different.
So I think that's it for the questions. Yeah, back to you.
Great, thanks for the questions. So keep them coming as we move along with the workshop. I think we're doing pretty okay with time. So now we will switch a little bit and zoom into the mmrm package as such, and introduce that a little bit, and then we will also later, after another pause for questions, start with a little demo, hands-on demo, where you will try this out yourself. So let me see that I can click here forward. Great. So first things first, installation of the package. Of course, as usual from cron, you can get it with install packages, mmrm. I just want to highlight that it lags a little bit behind at the moment. We have a little bit of a cron manual review bottleneck at the moment. As you know, we have the C++ code and stuff. So there are some nodes popping up when we submit the new package version. And then somebody from the cron team has to manually review this. And this might sometimes take a little bit longer. So if you want to have the latest release or development version, you can turn either to GitHub as usual with the remotes install GitHub path. There, I just want to say you need to have the C++ toolchain installed. So for example, on Windows, you need the RTools installation, and also just want to highlight it can take quite a while to compile this. And keep in mind that we have this TMB business, as I mentioned, this automatic differentiation going on behind the scenes that just takes a lot of time to compile. And another very nice alternative is to go to the runiverse page that is linked here for the mmrm package. And you can basically just download the binary package there for your system. So there's the Windows, Mac, and even I think Ubuntu flavors available there. And you can install then afterwards this binary package. Somehow for me, at least, when I directly go the install packages route and setting the source repo to runiverse, at least for me, it didn't find the binaries there. So that it would just default and again to the source package, which then you're basically back to this long compilation or that you need a C++ toolchain, right? Okay, so that's that. Just mentioning the features of mmrm, and here we're looking at a version of 0.3 or higher. So that's the latest release on GitHub or runiverse. Of course, we're talking about linear models for dependent observations within independent subjects. So there's no additional random effects that we can have or something. We just say there are certain kind of subjects. For example, in the pharma space, it will be usually patients or healthy volunteers or something. And they have multiple observations, and we want to assume that these observations are then correlated, right? And for these covariance structures, for this correlation, we can assume different models. Of course, if we don't assume anything, we can have any unstructured covariance matrix. We can do that, or we have the typical ones like triplets, autoregressive order 1, compound symmetry, antidependence. We also have some spatial, at the moment only spatial exponential, but others could definitely be added in the future. So please feel free to send us feature requests if you need other spatial or non-spatial covariance structures that can relatively easily be added by us to the package. And we also have this option for group-specific covariance estimates. That's pretty nice. So for example, if you have a clinical trial, you have 2 treatment arms, you might want to assume that this correlation can be different between the 2 arms, and that also works. You can also have weighted observations, so that's often used, for example, together with propensity scores. You can basically use those as weights then. In terms of estimation, as mentioned, we have restricted or just the standard maximum likelihood estimation available. We also took quite some care about the optimizers being used. So there's quite some options there for different optimizers to try out. By default, mmrm will just go through all available ones, standard ones that we have there for 5 different ones, and then take the ones that are converging to the highest likelihood value. We also added recently the robust sandwich estimators for the covariance. That's important if you are not using the unstructured, but you are basically having model assumptions on the covariance model. Then, for example, FDA or other regulatory agencies might request that you please use a robust covariance estimator, and that can be done with the package. And then, of course, as mentioned before, the core motivation for us to do this package was actually the degrees of freedom adjustments. And of course, degrees of freedom are important to calculate the p-values at the end. And of course, that's for your phase 3 study. That's going to be the key delivery at the end. Are you below the 0.05 or not? So we have different adjustment options here available. The Satterthwaite good old, but still useful choice. We have the Kenwood-Roger, but also the Kenwood-Roger linear ones. So you can, for your unstructured covariance mmrm, you can typically get very close results compared to proprietary software if you use Kenwood-Roger linear, for example. We have also simpler options like between within degrees of freedoms or residual degree of freedoms. They're basically not really adjusted, but they're more kind of old school classic degrees of freedoms that you might also wanna have. Great, so I'm turning over for Doug for the ecosystem integration.
Yeah, so Daniel covered a lot of the statistical niceties that are tucked into the mmrm package, and I'll talk a little bit about how it kind of then integrates with the surrounding statistical ecosystem, and then also what we use for the development will come in just a minute. So e-means was kind of the mmrm implementer before mmrm came around, and we still interface with that for this least squares means. And so that integration is still out there. Those two can kind of be used in conjunction with one another. More recently, we've been exploring tidy models integration. So this has been a request coming from the community and the users of this package that they want this kind of integration to fit within their workflows. And what we're trying to do now is implement this for the dedicated parsnip engine for linear regression, and then also integrate with recipes so that these things can be chained more easily into workflows themselves. Within Roche, we have this Nest family of packages, and that's since been open sourced. And so one of the early things that we had within Roche was turn.mmrm, and we're now working on making that also available through CRAN. So we're not just open sourcing, like contributing to the OpenStatsWare work through mmrm, but now also trying to make the available tooling that we've built around it also available to the community. Likewise, Teal modules clinical, that's more on the Shiny side, is how we then spin that up into a Shiny app so that you can toy around with some of these parameters and model fitting to easily explore the outputs that are produced with turn.mmrm. And there's plenty of third-party packages that we also want to integrate with. And I think we'll see in the hands-on session some of the interfaces to this to mmrm through the insight and parameters packages. Just to give a little more space to exactly how we manage unit testing. So you can find all of the testing on our GitHub page, on our GitHub repository, in the test directory. So this is just standard R package development practices. We use teststat as mentioned, and we use cover for trying to calculate the code coverage that we achieve. And we've hit a pretty high bar of over 95%. So that's for anyone who's done extensive testing, you'll know that things get a lot harder as you're starting to chip away at those last few percentages. And so this is really a hallmark of this project, is how rigorously tested it is. This also includes tests for the underlying C code. So it's not just the R code that has good code coverage, it's also the C code that we've implemented using the TMB interface that Daniel mentioned earlier. When we talk about integration testing, so this is testing against other software. We mentioned this tolerance that we're aiming to achieve, and we set a tolerance threshold that's 10 to the -3. So it's a pretty precise tolerance in terms of how we're aiming to match other software. And this includes comparisons with SAS using proc mixed and comparison to other R packages. So both of those we're very adamant about continuing to match those, and that's incorporated, like baked right into the testing strategy. Speaking a little bit more about benchmarking, so we've compared mmrm against a few other implementations, and just some highlights to emphasize the performance. So mmrm generally has a faster convergence time. And so if we use this particular data set as an example, we're a factor of 4 or up to 12 times faster than some of the alternatives. Both the estimates have somewhat small differences between proc glim mixed estimates. So that I think we have that kind of captured in a vignette. So if you really want to dig into the details there, you can go look at that on the mmrm package website, and there's a vignette there that kind of outlines all of this. And both these particular packages are also more resilient to missingness. And yeah, right here we have a link to the vignette. So if that interests you and you want to see exactly how these compare and how we're benchmarking these things, then this vignette will give you a better idea of what exactly that looks like. And just to highlight a few of the measures around community adoptions, CRAN, as far as CRAN is concerned, mmrm gets around 100 daily downloads. So that's quite a high mark. And the repo itself has over 70 stars. And now it is part of a task view on CRAN. So it's really gained some pretty glowing reception in the community. In terms of outlook, so for right now, we consider mmrm to be nearly feature complete. So the development's been ongoing for quite a while, and we still get a few feature requests just in terms of like integration with workflows. That's more kind of like how mmrm can be used and the types of workflows it supports. Those are more on the interface side, but as far as the statistical implementations go, it's more or less feature complete at this point. We still have a few major ideas in our backlog. So different types of ANOVA testing and evaluating rather simple random effects. And of course, if you feel like anything is missing, the best way to reach out to us is probably on a GitHub issue. So open a new issue, let us know what feature is missing for your use case, and then we're happy to kind of discuss and see whether that fits within the scope of the package, and possibly then incorporate that into something that will support that use case. And I think we're over to the demo. So I'll hand it over to you.
Thanks, Doug. Thanks, Doug. That's great. So here again, I want to pause briefly and see if there's any questions. Phil, how's it looking like with questions? Thanks, Doug. Thanks, Doug. That's great. So here again, I want to pause briefly and see if there's any questions. Phil, how's it looking like with questions? Do we have any questions that came in?
Hello, could I speak?
Yeah, we can hear you.
Yeah, sure. We can hear you.
Thanks. First, thanks so much for the fantastic package. I benefited a lot by reading the GitHub you wrote. So earlier you mentioned one good practice is to break the big task into small pieces by building helper functions and stuff like that. Sometimes the most difficult part for me when reading GitHub, our source code is, for example, when I click into empirical, there are setter suite, there are convert Roger, there are to see the bigger picture. Instantly, I see a lot of helper functions and small pieces here and there. So do you have any? Sometimes what I do is just browsing them within the GitHub to see the exact definition and how they are structured. Do you have some good suggestions for how to grasp the bigger picture here? Thanks.
Yeah, thanks. That's great. Great question. Yeah, so I think the methods documentation, so we have the methods vignettes that describe, for example, Canward Roger or empirical, sandwich estimator for the covariance and so on. We have dedicated vignettes for that, and that's the best for the high level picture, right? I would probably not in the first place go to the code directly, because as you have said, we try to split things up into multiple functions. So it's not like you can read within a few hundred lines the whole story there in the code, but it's better to look directly at the vignette, because there we really try to describe this high level picture and really staying relatively close to the statistical methods, nomenclature and so on. So that's probably the best starting point. And then if you want to dig into the code, then you can look into the code. But I would really start with the methods documentation, because there you get the high level picture. Yeah.
Thank you so much.
Any additional questions or comments?
There's a few in the chat box if you want me to read those, Daniel, to you.
Yeah, that would be great. Maybe that's.
So there's one here that says DevTools package has many functions to build packages, which is quite different from TMB. I don't know if that's more of a comment, but I didn't know if you had anything to say to that.
I get, yeah. So DevTools is a great tool, and we also use this, of course, and of course it's also very nicely integrated into our Studio IDE. So I'm also using this a lot every day. So by the way, thanks to everyone who for building this. So the TMB again is a little bit more specific thing that we mainly just use for the C++ framework here and for the automatic differentiation, and probably it's too specific that DevTools would support this directly with additional helper functionalities. But it definitely, definitely works kind of still together in some sense, right? I mean, we're still building an R package. We still need things like load all and so on. For example, DevTools is also clever enough that when we say load all, and we had some changes on the C++ side, it will recompile those necessary object files first, and then make the let's say updated version of the package, including those updated C++ functionalities available in the console, right? And that's super helpful.
So you mentioned, oh, go ahead. Sorry about that.
I was just gonna quickly add, the template part of TMB can be a little bit of a misnomer when trying to look at it in the context of package development. So the template part is for templating like the C implementation. So you can still use that template structure and all of those constructs that this TMB library supports, while still using all of the typical package development tools.
Yeah.
So those are kind of two different parts of the architecture.
Yeah.
So two more questions, I think. One is, are C++ functions used outside of R packaged? Are C++ functions being used outside of R package?
In this case, not. So basically, in this case, we don't intend to use the C++ functions we have in the package outside of the package. I mean, we would basically always use them via the package interface. That means via our functions that basically then internally basically call those C++ let's say counterparts, right? So we don't intend to call them outside. Yeah.
It's kind of a cool idea though. Like if there was a need to, use this from, I don't know, some other language, if we wanted to write a Python module for this, for instance,
right,
we could think about wrapping all of that C code into its own C library and then just calling into it. But that's a pretty big deviation from how it's designed right now. So unless there's a really a push for that, I think that's probably not how it works currently.
Yeah.
So last question here, it says, what I have done in the past is to write some part of the code using RCPP to speed up any function slowing down the packages. Am I doing something off?
No, that's a great strategy. And actually I didn't mention this in particular, but we also actually use RCPP for some of the parts here in mmrm package. And yeah, and typically that's exactly how you would use RCPP, right? I mean, you would first start writing your package just in R, because that's much easier to interactively debug it and see that you're hitting the right results. And then you can benchmark with, there's a couple of nice tools available in R where you can really see where is the bottleneck in terms of performance. And then if there's really like this one, I don't know, double or triple nested loop, for example, that's a typical thing that you need to speed up, and that that's kind of where the majority of time is spent during the model fitting. If you can then refactor this thing in RCPP and get like a tenfold or whatever kind of speed up, that's of course great. So that's definitely a valid strategy. Yeah.
All right. If you'd like to go off mute and ask a question, feel free to do so. And otherwise, we'll go ahead and pass it back to Daniel. Just give you a second here. Once, going twice. Daniel, I think it's back to you.
Okay, awesome. So yeah, keep those questions coming. Very, very cool. So now we will have a little bit demo time. So you will be able to try this out hands-on when you head to this tinyurl.com/mmrm-workshop link. And I will do this here directly as well live, so you will see the steps. But we will basically go into this mmrm workbench space and then open the introduction. So let me let me do this here live. Hopefully everything will work and you will continue to see my screen. Just gonna move this Zoom thing here. So we go to this page. This gives us the POSIT Cloud invitation that we can join the space. So basically now you can click on join space, yes.
And can you confirm, Phil, that you guys are also seeing the POSIT browser tab?
Yes, we can see the POSIT Cloud perfectly, and Daniel is walking through how to get into POSIT Cloud. I put the link in the chat box. I'll put it again. And if you have any questions, feel free to reach out to me.
Awesome, great. And now basically we are welcome to the mmrm workshop space here. And we see on the left-hand side, you have been added to your existing spaces. You should see here now on the left, when you click on this little outline, 3 lines kind of icon. Yeah, you should see here the spaces, and you should see that the mmrm workshop space has been added probably on top, and you can click on this one. Then you see the content, and we have here as a single content the scripts here. So you can click here on this little link, mmrm workbench, answer them. But this should be fairly easy. And you can log in, for example, I think with GitHub, ID also into POSIT.cloud and stuff like that. So that's also relatively easy. So what we get in the end is this nice little RStudio session here. And here in the files section, we want to open the mmrm introduction.rmd file. Okay. So now we have this here. We can make this a little bit bigger when we collapse this thing here. And we can maybe even make it, can I make this full screen? Not sure. Somewhere should be full screen or something. Oh yeah, great, thanks. Cool. Okay, so something like this, then we have a lot of space. Okay, so basically now, just wanna, let's walk through this together, and you can do this in parallel on your session as well. So of course, in this just to mention, in this workspace, we already installed the latest release, again, the 0.3.4 version. That's again, as mentioned before, that's not yet the crown version, but it's the latest release that we have on the rUniverse and GitHub. So we already installed this for you, so you no longer need to do this here yourself. And we can directly just go here and load, for example, the package. Just getting rid of this Zoom thing. Okay, cool. So the simplest thing in with the mmrm package is just to fit a model, right? And you need 2 things for that. You need the formula that describes the model structure in the usual form. So you have the outcome on the left-hand side of the tilde, and you have your covariates on the right. And in addition, you have the covariance model specification with this additional special terms here. So we have 1 special term per formula, and this basically tells us what's the structure that we want to use. Here, just unstructured, short here abbreviated as US. So it doesn't mean United States, but it means unstructured here. And we have the variable name for our identifying our subjects. So those things that are independent from each other. And then we have the column name in our data set that identifies the visit or the time points, basically the different observation indices that are basically within these individuals, right? So that's basically the structure of the special term. And we can then also give it, of course, the data set that has those variables in it, right? So we can look in this data set quickly, and we see that we have all of those, and we can get this fit. Okay. And when we look at the printout, so when we just type fit, we just look at the model results. We try to have like a little bit familiar format. So basically on top, we just describe some high level properties of the model. So we get again the formula here. We see the name of the data set that has been used. We see the number of observations and subjects. What was the maximum number of time points for these subjects? We see the covariance model being used, how many variance parameters we had here. because we had maximum 4 time points, we can calculate here that we had 10 variance parameters. We see the inference, so here it was restricted maximum likelihood, and we see the model deviance as well. And we get the coefficient estimates and a message here on the optimization convergence, right? If we want to see more details, we can have a look at the summary of the fit. In particular, we get here more details on the degrees of freedom adjustment. So here it was Satterthwaite, as well as the covariance matrix. Basically, the that's not the covariance model for the observations, but that's the covariance matrix of the coefficients, the fixed effects. Here we just use asymptotic. And we get here some model selection criteria, the typical ones like ASA, BAC, the log likelihood. And we also get the coefficients table that you will also see from other standard, for example, linear model LM functions in R, like with the standard error. Here, the adjusted degrees of freedom, the corresponding t statistics, p-values, and the usual asterisks for the significance levels. And we also see the covariance estimate, right? So this is now the estimated covariance matrix that we have here for our little data set, right? For the 4 different time points. We see that here. Any questions maybe so far? Is that clear, all the basics? Any questions on these basics that came up?
Yeah, there's a couple questions here. Let me see if this one. I said, sorry, I missed it. How can I get the MMR introduction? I think they're just asking about maybe getting into Posit Cloud. I'll put that in the chat box, but I think the key thing, Daniel, is just having them click on the RMD once they access the classroom environment. So I'll put that in the chat box. And then the next one, let me see. I think we're good. Other than that, the rest of them are just about asking how to get into Posit Cloud, and I will address those. So
Thanks.
Keep on going.
Great. So let's talk about some customizations that you might want to apply here for the model fitting. Just to mention, we will not use that much later, but there's the mmrm control function that can be used to kind of bundle different arguments kind of together. You might, for example, use this once and then reuse it later over and over again. So just to mention that this exists, but we will actually below just implicitly just pass the arguments directly. So let's talk about different inference method. We can update, for example, our fit and use maximum likelihood estimation by saying RAML equal false. So we don't want to use RAML. That means we want to use maximum likelihood. There's no other third inference option. And that's, yeah, it's nice that this kind of works. And we see that then reflected here. Inference is now ML. We will see slightly different results regarding deviance and the coefficients and so on. And it's also nice to see that the update method actually works very, very nicely here. We can check which optimizers were used when we look at the attributes of the fitted object. Here we see the LMB optimizer was used. Sometimes you might want to manually control the optimizer. You can do that with the optimizer arguments, or for example, BFGS is another option. And we can confirm with the attributes again that it was actually used here in the end. Covariance structure, of course, that would be something you might play around with a lot. And you can just use these different acronyms. For example, compound symmetry is specified by using here CS. And again, we can just update our fit here with that. And we see here that we now have this compound symmetry covariance model with just 2 variance parameters specified. If you want to have a full overview of options for the covariance types, we have this dedicated page that is very, very easy to see here in this little table what covariance structures are available and what's the acronym that you need to use here as the special term, right? So before we have used CS just now and unstructured, and we see the entries then defined of this covariance matrix, and we also see how many parameters we have, and we also have the spatial covariance structure, the exponential one at the moment here available. So other optimizations, you might want to use weights, and that works with the weights argument. You just pass it a numeric vector as typical, also for other model fit functions. And we see this here mentioned, and we see that things have been updated. Group covariance structure, as mentioned before, that can be pretty useful. The syntax here is that you basically have an additional nesting here. So we say again, special term here, compound symmetry. We have our time points given the treatment arm that is kind of containing the subject. So it's with this little additional slash here that differentiates the group variable, for example, here the treatment arm and the subject identifier on the right-hand side of it, right? And we can, again, update our model with that, and we can actually see when we access the covariance estimates with, for example, VAR-core directly, we can see that we now have one covariance estimate per treatment arm. So we have one for the placebo arm and one for the treatment arm here as a result. And we actually see that they look quite different here, right? Degrees of freedom method, as mentioned before, we have a couple of options. This is available via the method argument. So typically you might want to use, for example, Kenwood-Roger. Just a quick note, you need restricted maximum likelihood estimation for this. By definition, and just from the methodology, Kenwood-Roger adjustment does not work with maximum likelihood inference. So just with ML, it only works with restricted maximum likelihood. Okay. And when we look at the summary of this result, we can see then here again the mentioning that both the degrees of freedom method as Kenwood-Roger, but also the variance covariance matrix, as you might know, Kenwood-Roger really works also via dedicated covariance estimation for the fixed coefficients. And other choices are available, so you can look at this mmrm control page to see a little bit more different ones. I just actually, when I prepared the workshop, I found that this was not so nicely formatted yet, so we will improve this. I already spun up a new GitHub issue for this, but you will see here that we have different VCOF methods, we have different methods options as well. And there is some kind of correspondence that we say, if you have certain methods, then we have a certain VCOF by default. This should be here in a table. Unfortunately, it's not yet formatted as a table, so we will fix this. And again, the mentioning, I mentioned this already before, but if you want to use unstructured covariance model and you want to match SAS results as much as possible, then you should use Kenwood-Roger linear for the VCOF so that you better match actually the SAS results. Okay, so that's like a special case. Robust sandwich estimator, as mentioned before, when you use a structured covariance model, the robust sandwich estimator ensures that inference is unbiased, even if the covariance model is misspecified. So that makes things much more robust. You can choose this, for example, with VCOF equal empirical. And you can again see this in the summary that this has actually been used. So we see a VCOF method empirical. Okay. Okay, I will make another pause here and see if there's any questions.
Yes, someone said that they missed the commands that you inputted in the console after the library mmrm. So maybe show the console that you worked with.
Yeah, so the important thing is just that you find the mmrm introduction RMD file, because that's basically what I walked through here. I think I didn't even type something myself.
Okay. Okay.
So just I don't think I put, let me see, or maybe I did something. Oh yeah, I just looked at the data set, right? I just said head of the FEV data. Maybe they meant that. But otherwise, I'm following the Markdown document pretty accurately. Yeah. Any other questions?
I think that's it. One may have, oh, they got it. Perfect. Thanks, Daniel.
Okay, cool. Thanks, Phil. Okay, with that, I hand over to Doug to show us a little bit the ecosystem integration.
Yeah, sure. So like we mentioned, mmrm does a really solid job of covering a lot of bases in terms of the optimizers, the ways of articulating degrees of freedom, and you can control a lot of that, and it's very well documented. But in addition to all those things, it also sits nicely into a bunch of different ecosystems to kind of slot more familiarly into your existing analysis. So one of the things that we do is that we implement a few of these or methods for a few of these generics that let you sit more nicely within kind of the tidy framework. So we can see what wrapping a fit looks like in terms of a tidy structure. So this is using the Broom package. And this kind of, the Broom package, for those that aren't aware, is a way of kind of wrapping various objects that can be a little hard to tease information out of into more kind of standard tidy structures. So these are generally long data frames that can then be piped into things like analysis. So for instance, if you were doing this type of analysis, but you iterated over a dozen different models or something like that, you could easily collapse this into a very long data frame where you might have another column on the left that says which model you actually fit, and then gives you all these different terms. And then you can easily like compare models that way. So this is a really nice way of kind of when you start expanding your analysis into something that spans multiple models and you want to do model comparisons, the Tidyverse has a lot of tools that kind of make that more familiar, and we slot nicely into all those tools. Likewise, we mentioned during the slides that you can use this e-means package to then calculate these least squared means. So when you load e-means, we actually register this mmrm function as an e-means extension. So we kind of hook into that loading of e-means. We do a little bit of extra legwork to make sure things get integrated nicely. And what that means is that now we can use our mmrm fit object to calculate these least square means. So if you've used e-means, this hopefully looks familiar, but you can already see then that the output looks more kind of like idiomatic of what you might expect coming from the e-means library or package. Like I mentioned, a lot of the other the Tidyverse tools work very nicely, but also the Tidy models tools. And so if you're now adopting a lot of the Tidy models workflows, then hopefully this will work nicely for you. This stuff is a little more in active development. We've only kind of been responding to specific people's needs as they come up. So if you use Tidy models and you're rather an expert in this space, try it out and let us know if something doesn't look necessarily like you expect. Then let us know what you would want to happen, because we're also still trying to anticipate those needs. And we can see right here when we loaded Tidy models, we can see that mmrm's mmrm function is now registered. So Parsnip is one of these packages from the Tidy models cohort, and it's used then for kind of registering models into a more Tidy models native structure. And so we can see that when we use set engine, we can now you can use this registered model. We can specify a lot of the different parameters that we were specifying using the mmrm function. So we can see that we can set the engine, we can set various methods that we want to use. So these would be options that then get passed on to the mmrm function. And then we can also pass this fit object in our data, as you might expect from the Tidy models world. So we can see what that looks like. And just like before, we're getting our model output. It's now a Parsnip model output object, as opposed to purely an mmrm fit. But this all looks very familiar from what we were seeing previously. So you still see a lot of the same mmrm fit object information. If you've used Tidy models quite frequently, maybe you've started wrapping things into workflows. That's more of like a bespoke pipelining framework specifically for model fitting. I'll just expand this a little bit more so that the formatting looks a little nicer. So here we're defining a model specification. We build a workflow, and then we pass the workflow, or we pass data to the workflow in order to make a specific, fit the specific model. And so this is that kind of that situation that I mentioned earlier, where maybe you might want to make a workflow that you would then want to pass multiple different data sets through. You want to do it reproducibly. So you want the specification and the workflow to be something that's kind of held constant, but then you want to pass multiple different data sets. So this is a great framework for supporting that type of structuring of your analysis. And if we just run this, we'll kind of step through a few of the results in here. So somewhere in the middle, we produce this mmrm specification. We produce a workflow where we specify our variables and our predictors. We specify our model, and we give it here the specification from above. And then with that workflow, now we're just passing it this to this fit function with that particular data. And so we can see a lot more, nicely formatted input that tells us more things about our tidy models workflow. We can see a lot of the information that we specified above. So we can see all of our predictors and outcomes that were specified here. And then, of course, we see our same model as before. Likewise, tidy models has this concept of a recipe. And this is more of a reusable way of specifying a model and some of the pre-processing steps as well. And so we can integrate with those just as well. And so if we produce an mmrm recipe, here we are defining, again, our formula and our data. We're maybe pre-processing some of our data, some of the variables that we want to use. We can specify interaction terms so that they automatically get derived when we are wanting to then train our model or fit our model. And then you can use these kind of like, cute function names that come from this recipes package. You can prep your recipe and then juice your recipe. I'm going to have to refer to their documentation for exactly what all goes into those steps, but you can kind of view the resulting data transformation once those steps are applied. So here we can see that the ARM codes have been kind of encoded then into separate variables, and that was what we were specifying up here. Once again, if we wanted to specify more of these parameters about our model, we can do that within the set engine. So a lot of the variables that are handled through the mmrm function are also accepted here. That means that we can specify pretty much all of these different considerations that you might apply to your model, specifically within this construct. And specifically, I'm going to call out this as covstruct. So we mentioned previously that you can specify a formula with a built-in covariance structure, but you can also specify it, like build it as a separate term. So if you wanted a particular covariance structure, but you wanted to apply that to multiple different models, you can now kind of mix and match those things as part of a more engineered workflow. And all of those things will kind of like couple as you're defining them in different parts of your tidy models workflow. So this one doesn't produce any output, but we'll use it just below. So when we're building a workflow now, we can specify this covariance structure. Here we're giving it the formula. So you could imagine this could be looping over multiple formulas and we're producing different workflows, or mix and matching covariance structures if you want to iterate over those to see what that looks like. So this is just how we would then combine those and produce a new object, specific workflow with this particular covariance structure that we specified. And if we just look through this, we can see kind of the different pre-processing steps that we used. And now we can even see the covariance structure that was passed to the engine. And finally, we can then use this workflow output, there's a generic to fit our model, and we can finally see what that looks like. So I think here we'll extract a few elements. So Hardhat is another one of these tidy models packages. And now we can kind of extract information from our tidy fit. So if we do that, here we have our mmrm fit. This is the same one that we would have had if we would have fit it on its own. So you can also do it that way. That can be a little more extensible if you end up kind of really engineering a whole analysis of different comparative methods, and a really nice way of just kind of engineering your results. There's two other packages, and we just wanted to, these ones actually suggest mmrm, is that right? And so these are other packages that have now kind of adopted the mmrm package and they want to integrate with it. So it's kind of nice to see that adoption within the community. And we're just going to show that they have a few methods that then also operate on an mmrm fit. So we can see what that looks like. I'm not terribly familiar with these particular packages. So for the details, you probably have to refer to their documentation. But suffice it to say, it's an endorsement of the package that it's getting this kind of adoption and being incorporated. And if you are using these actively, it's nice to know that the mmrm is well supported. So I think that's about all we had planned, and we've hit the end of the notebook now. We can probably pause again for questions, then we just have a few slides now to wrap up. I'm monitoring the chat now over here, so I haven't seen anything new pop up. If anyone wants to come off mute with questions, that's also fine. I'm seeing one. I'll read it out if you want to answer,
great.
Daniel.
Yeah.
So the question is, can you explain a little bit more what the optimizers do and what are the differences of different options?
Oh, right, sure. So maybe just coming back to the basics, right? So basically how this model fitting works is that we have a function in our package that calculates the likelihood for different parameter values, right? So if you take different beta coefficient values, different variance parameter values, depending which values these have, which numbers we put in there, we get a different likelihood value, right? And the model fitting works that we just want to find the maximum of this likelihood surface with regards to the parameters. So what are the parameters? What are the numbers for these betas and these these covariance parameters that give us the maximum likelihood, right? Because those will then be our maximum likelihood estimates, right? So as mentioned before, we have the great advantage that we actually have both the likelihood value as such, but also the gradient of this function, of this likelihood function. We have that available very quickly and very precisely because we use this TMB framework with the C++ implementation. That's a big help. Now, what we are still doing from the R side, we're still using R, let's say, available optimizers in R, right? So there's a couple of ones that are available in the let's say standard packages, and we are basically making those available here to the user. And because there's different ways to optimize this function, right? You might use Newton-based methods. You might use more like conjugate gradient methods. You could even think about using stochastic kind of optimizers. At the moment, we don't have this as an option directly in the package, but let us know if you need something like this. But yeah, that's basically that's basically what this optimizer means. And in terms of options, let me just quickly have a look. I think we also have this listed in the mmrm control page. Let me just quickly confirm this. Yeah, well, it's a little bit, maybe a little bit more hidden. So we have here mmrm control. We see here different optimizers. And I think we have this here under hget optimizers. So there's just, yeah, so here we have the available options. So at the moment we have 4 different standard options available. It is actually, yeah, sorry, I forgot already. So it is actually possible to put in your own optimizer function. So there's a couple of contributed packages on cron, for example, that provide additional optimizers in addition to these standard ones. And this might also be, let's say, an interesting idea in some cases where you maybe have trouble to achieve convergence. So basically find those maximum likelihood parameter configurations with these provided standard optimizers. Then you might want to look into providing your own optimizer function, right? And that's actually also possible. You see, I haven't worked with this for some time now, so it's even for me as a maintainer, it's even helpful to have this documentation, right? I hope that answers the question a little bit.
Yeah.
And for the difference between these different optimizers, you would then you can then look at the documentation directly. So because that's available from the stats optim and also stats NMB, and you can then click on this and read the details of these kind of differences, right? So they will describe more or less in detail what do the different options mean. Yeah. Any other questions? You can get off mute or you can put it in chat, whatever you prefer. So we have a question. Thanks for the neat RMD to play with. What did MMT to specifically to ensure that the package is extensible? Yeah, a good question. It's not the object-oriented strategy so much in this package. It's more kind of the strategy of providing entry points, for example, like the mmrm S3 class definition, but also implementing a lot of the standard methods that you have for model fit objects. So these are things like, things like formula, that you just apply formula to your fit, that you say terms of your fit, that you say summary, that you say coefficients, that you say log likelihood, and so on your object. So this is something that many people expect in terms of how your model fit object should behave, and that should actually make those things available. And because we have this, then it also gets easier for other packages. For example, we have seen the parameters and the insight packages just now. It gets much easier for them to integrate then as third-party packages with our package. So I would say that's kind of the most what we did in terms of extensibility. Maybe what we have not done, and what we could also have considered, but we have not done. We have, for example, not made it as extensible in that way that the user could specify the covariance model ad hoc, right? So that's not possible. So it's not possible that you say, I have my Daniel covariance model and I want to fit my mmrm with a Daniel covariance model. That doesn't work as such. You would then need to go the way that you basically make us a feature request and say, this is Daniel's covariance model is structured like this and like that. These are the formulas. And then we can implement it into the package directly, right? So that's something we didn't do. Some other packages allow for this because we have the C++ route for the TMB and so on, as we discussed before. That would make things quite a lot more complicated to make that extensible, let's say from the user side.
Maybe one other point though, we just showed the optimizers function that you can pass,
Yeah,
and those types of things are
yeah.
really nice for extensibility. That's not an object-oriented style, or maybe not, in its like refined form. That's more of like a functional style. But that mechanism of just providing hooks where the user provides effectively executable callbacks that we can use to do this optimization.
Yeah.
That's a really good way of kind of like providing these extensible interfaces. I think that's more of like a functional style if we kind of compare programming styles, but and I think that's actually a really powerful design tool. I think it can also be the barrier to entry, I think, for passing around functions as interfaces is a little higher. So that also means that like we kind of reserve that behavior as more of like a power user kind of interface. There are a couple of other questions. Do you want me to read those out to you?
Great.
So we have one question. I'm just wondering if you could provide some ways of doing parallel computing in a package building.
Some ways of doing parallel computing in a package building. So, I mean, maybe to come back to the mmrm package, what we are actually providing also as an option here is regarding these different optimizers again, right? If the default optimizer does not converge regarding this maximum likelihood estimates, if it doesn't find this peak of this maximum likelihood surface, then we actually, as an option in parallel, fit the model with the 3 other standard optimizers. So we actually have also this option to do some kind of parallel computation as a feature of the mmrm package inside. I would say in general, there's different options available with different kind of complexities. If you want to keep things very simple, you probably just go to this parallel MCL apply route. That's kind of the easiest thing to do. Unfortunately, that will only provide parallelization on Unix-based systems. So that will not give you parallelization on Windows. If you want to also do parallelization on multiple cores on Windows, things get more complicated. And there's other frameworks to do that. But yeah, I think that's maybe just a high-level answer to give you a little bit of a direction.
And I think we have one more, and then I think we'll be okay on time, but that'll take us, I think, right up to the end. Asking about when we might expect a 3.0 release. Is that something insight for 2023?
Yeah,
to CRAN specifically.
yeah. So it's actually it's 0.3, not 3.0, but yeah,
Yeah.
it's a minor version 3, exactly. So yeah, I mean, hopefully very soon. I'm hoping for a positive response and a message. Thanks on its way to CRAN now from Uwe Ligges any day now. Honestly, in my inbox. So far it hasn't arrived yet, but it's basically ready, and that's why we also showed the version 0.3 today in this demo, because it's basically ready and it's ready to be used in production. So I think it's fine to go, and hopefully it also comes to CRAN soon. But unfortunately, I cannot give you any concrete timeline.
And I think maybe just in the interest of time, we'll move on with slides, but I saw a couple other questions trickle in at the end. We can answer those after we've gotten through the rest of the material, but
Exactly.
hopefully we'll circle back to that soon.
Great. Thanks, Doug. Thanks, everyone. So let's talk a little bit more about the open source development aspects of this mmrm package, because that was also, I think, is a highlight for me personally of this, of this, how it worked out in the end. It's not just about the end product, but it's also how we actually arrived there, what was the path there. Here I want to introduce the Open Statsware working group, which was founded a bit more than a year ago. So we just had our first birthday. It's an official working group of the American Statistical Association Biopharmaceutical Section. That's a little bit a mouthful. You can also say ASA Biop. Initially, it was only 11 statisticians from 7 pharma companies developing statistical software that were interested to join forces. And we recently rebranded this from Software Engineering Working Group to Open Statsware, which is much easier, hopefully, to remember, to keep in mind. And mmrm was really our first work stream. And it really came as a product, as a package here out of this Open Statsware group. Maybe just 1 or 2 words on why was this topic important. mmrm is a popular analysis method for longitudinal outcomes in randomized clinical trials. And it's also used as a backbone for more recent methods, for example, that are multiple imputation based. For example, there's the RBMI package that we also have published on CRAN that's using mmrm package under the hood as a backbone. And we also have a second work stream that produced a similar package for actually Bayesian inference in mmrms. So not the maximum likelihood, but not the frequentist inference or likelihood-based inference, but the Bayesian inference path. And that's based on BRMS as a stand front end for the Hamiltonian Monte Carlo sampling. So that's called brms.mmrm. Please check that out. That's also on CRAN available. A little bit on the success factors here from the human side of things. We talked a lot about packages, but there's also people involved. It's really important that you have shared interests, but also trust each other when you are embarking on such a project. And yeah, just as humans, it's important to get to know each other first. And we have bi-weekly calls in the Open Statsware group. We just, for example, have another one coming up tomorrow. And although it's mostly just online, it helps a lot to connect with people, to get to know people, and then you can start working together with them much more easily. And I personally think, just having this mindset of reciprocity is super productive. So what does it mean? So reciprocity means that in response to friendly actions, so if you're friendly, then people are actually frequently much nicer and much more cooperative than predicted by the self-interest model. So basically, if people are actually better than maybe you might assume. So if you're a little bit friendly, maybe they are even much more friendly as in return. And in my personal experience, if you first kind of give away something for free, for example, a little package ID or a little prototype that you had in the beginning, you open this up to the open source community or to your working group and say, let's join forces together, it will actually be much more fun and more will come back to you in return, in comparison to just, keeping things secret for yourself in your little chamber at home and trying to build everything alone, right? So it's pretty powerful. That's yeah, a segue to this slide. I think it's important to go public with your idea and your package idea as soon as possible. For mmrm, we did not wait for this to be finished before the initial open sourcing, right? Basically, just right after the initial prototype worked, I immediately open sourced this, and we started to work together, because then you can have really many developers contributing over time and kind of owning this together. Everybody becomes author and so on. So building a software together works much better than alone, in my experience, because you have different perspectives, right? It's not just your own single perspective, but you have multiple perspectives in the discussions. You have code review by people, and it helps to keep the code readable, helps to really optimize the results, and really the user interface and the experience for the user as well. And I would just recommend, be generous with authorship on these projects, right? For example, in mmrm, everybody that contributes a pull request becomes an author, independent, whether it's 10 lines of code or 100 lines of code, right? And that, I think, helps also to to grow the adoption also of this package. So we'll hand over to Doug to tell us a little bit more about the daily process we have here.
Yeah, so just to give a little bit of a case study for what this looks like in practice, I'm just going to walk through kind of what the ideation and implementation of this particular feature went through. And this will be something that's coming up in the 0.3 release that hopefully hits CRAN before the end of 2023. So the simulate feature, this is the ability to produce data based on a model. And so we want to see now, what does it look like to think about that as a feature set, and how do we then kind of feed that back into the reflections that we have on the project, and how do we then give feedback during an implementation? How do we divide up work? What does it look like then to incorporate that feature? And so if you're familiar with open source development, maybe this looks really familiar, but there's a lot of people that haven't kind of dove deeply into this part of the development process. So I wanted to kind of pull back that curtain a little bit. And certainly if you aren't necessarily familiar with it so far, but you want to be, then hopefully this gives you a glimpse of what that'll look like. So it all starts with open communication. So as we're designing a new feature, here Daniel is proposing that we add the simulate method for this particular object, and that would let us then kind of achieve this fairly standard practice for any kind of modeling package. And so we see some of the comparisons here. So there's a articulation of what the feature would look like, what Daniel sees as some of the needs for what it would entail. And you don't see it here, but if you were to scroll down through this whole page, you would see a long list of discussions around what exactly that feature should look like, some ideas around how it could be implemented. And we can kind of see up in this little corner that there's 18 comments where this was kind of going back and forth. And we ultimately decided, or here, Dan, one of the contributors, took an interest in this particular work and agreed to eventually take it on. Like Daniel mentioned, this is also supported by frequent calls. So currently those are bi-weekly, but as the project matures, that can fluctuate. This live chat is really good for this initial planning period when ideas could be kind of all over the place. Everyone has maybe a different perception on how things could look. But also at the very end, when most of it is kind of in place and you're just trying to figure out how those final details need to look. In contrast, I think the async discussion threads really also have a major place in this, where those kind of add a lot more value. Things where you kind of need 20 minutes to sit down with an idea to really poke holes in it, to provide valuable feedback. So there's, in both cases, you can kind of defer to the other one when maybe communication, it lends itself better to that kind of communication. So async discussion threads, this would be like your GitHub issues or pull request discussions. Those are great for mocking up proposals. So if someone has an idea of what this interface could look like, maybe that takes a few iterations on their side to really tease out the details of it. And that having that time away from having other people reflecting on the way that you're thinking about the problem helps you kind of focus that energy a little bit. Especially when you're developing visual or code-based content. So this could be APIs for users, or diagrams, or workflows, or breakdowns of how classes and class structures should be talking with one another. These are more like the technical details that might happen behind the scenes. Thinking about those at depth is really a necessary precursor to really having a productive conversation. So this encompasses a lot of the technical details. And this is a lot of stuff you'll see in those discussion threads that we just showed. So As after Daniel proposes this initial feature, someone might think about what are the different maybe parameters that we need, and how would someone articulate these different use cases and things like that. After we've decided on design, at least as much as we can foresee from the outset, then there's an initial implementation. And this initial implementation doesn't necessarily need to be the final implementation, but it should kind of articulate that design philosophy as closely as possible. Usually in the process of implementation, you discover things that you didn't even consider, nuances with how the other parts of the software interact that you need to now anticipate. And I think it's a good practice that some individual can kind of like get over those initial hurdles and then report back what were those things that actually weren't as clean as you might have initially intended. So that initial work can proceed with this confidence about what needs to happen, but there still might be this uncertainty about how it needs to happen, and surfacing those kind of like reflections back to the team is kind of this like final feedback loop. And that feedback loop happens in review. So here's just one screenshot I just kind of dug through for something that fit nicely on a page. But there's plenty of other review discussions like this where someone is identifying a bit of code. Maybe there's something else, some other way that someone's thinking about this problem. They can provide that feedback and maybe suggest an alternative. And it's really nice that we kind of have this flexibility then to do this iteration and resolve those conflicts between other different interpretations of how code could look, and settle on something that sits nicely within the design philosophy of the package as it exists. And when everything looks good, everyone agrees that any of those concerns have been addressed, then the code gets reintroduced. So that's just a little story of like this particular feature, and it's very emblematic of how most features are incorporated into the mmrm package and open source tools in general. And hopefully that gives you a better idea of what to expect if you do, circle back to our issues inbox to suggest something new. So I think I'm handing it back over to Daniel to wrap this up.
Great, thanks, Doug. There was just a nice little workflow illustration from Doug that was really useful, and I think really people can benefit from this kind of workflow for their projects. So just to summarize what we covered today, so we showed you some practical steps for going from a statistical method that maybe not you have invented, but somebody else, and then getting a implementation in an R package from that. We discussed some key considerations in this process and illustrated these with the mmrm package example. And then in the second half, we looked at the mmrm package in particular, and did a little bit live demo there. And we also showed you how it went working together across companies and in the open source world on this. So I want to give a special thanks to all the mmrm contributors here. In particular, Julia Dedic, also Kevin Kunzmann, Brian Lang, Li Ming Li, Christian Stark, Ya Wang, Craig Gower-Page, Dan James, Jonathan Siddy, Daniel Leibowitz, and Daniel Searberg, in addition to the two of us. So thanks, everyone. And of course, new contributors are welcome anytime. And with that, just wanted to open up if there's some final questions or comments.
We had a couple. Maybe the first or the second might be a little easier to address quickly. Has the mmrm package been used in FDA submission?
Great question. As far as I know, at least I haven't heard of any particular FDA submission, but it would be great to hear if somebody maybe does that. Please let us know. That would be a great, of course, success to hear about that. I definitely want to say we would have had probably a submission that uses the package already if a previous phase 3 study in Roche would have been positive, because it was kind of planned to be used in conjunction with our BMI for that one. So we definitely had planned for that already. Yeah.
And then we're closing into time. So I'm not sure if we have a little bit of extra bandwidth to answer a few more questions, but if people need to hop off to the next workshop or whatever else is planned,
it's okay here, Doug, but it's completely on you. If you guys got to jump, that's fine. If you want to keep going, that's fine too. Either way works.
Okay. I think
we'll just quickly open it up if anybody wants to ask any question.
Yeah, we still have a couple there unaddressed. So I can,
Okay,
I'll
great.
continue
Yeah,
reading those out.
let's hop back to those.
Does this TMB dependency that we're using allow using existing R packages as dependencies? And if yes, how could we do that?
Does TMB allow using existing operations as dependencies? I mean, for sure, mmrm has other dependencies besides TMB, if that's maybe what's meant. Otherwise, we would probably need to talk more offline to understand the details of that question. But yeah, it definitely, let's say, it plays well together with everything else, right? It's like RCPP. It's a framework for the C++ backend of your package, and it still plays well together with other dependencies that you might have. Yeah.
Yep. And we had, are the slides available? And yes, they're already up. So thanks to the host for posting those. And then we had one other question regarding the tolerance that we set. Just curious about the relative difference of 0.001. Is this acceptable in pharma studies?
Great question. So the good thing is that, you know, and let's say, you know, regulators or other stakeholders understand more and more that there is not one you know, a gold standard implementation of all methods available. And there's other alternative implementations of methods. And we have also a dedicated working group, the CAMIS, or CAMIS working group of PSI, that actually is specifically documenting differences that you might see between different softwares implementing the same kind of statistical methodology, and just making people comfortable, you know, documenting to people in a very explicit way that it's actually okay that we have small numerical differences between different softwares. That's just a, you know, an artifact that is driven by the floating point computations we have in nowadays computers, right? There's no absolute precision for these kind of things, and that's completely okay, right? Of course, that's a very big differences, of course, would not be okay, but with these smaller differences, we're definitely comfortable, and also regulators, as far as I let's say, have heard, and we have discussed, and we have seen in other ways, we are definitely comfortable with this.
Yeah, I can definitely speak from the R validation side of things, that our conversations with regulators is that they're comfortable with slight differences in methods, and they're more concerned with the application of the method and whether those slight differences result in a difference of interpretation of the conclusions. So from what I've understand, they also like, you know, fuzz testing a few of these methods, trying different optimizers, and if they were to even use the same package, or trying a different implementation of the same methodology, just to you know, fuzz test it a little bit. So if you see things that influence the statistical conclusions of a result, or if you're right on the border of a, you know, statistical cutoff, then like anything else, I think we shouldn't hold those like p-values of 0.05 to be like you know, a deciding factor always for exactly what is and isn't significance, but rather when you're close to that border, being critical about the methodology you're using. So in that sense, having this tolerance, trying to get as close as possible is always great, but then being reflective about what that means for your methodology.
Great.
I think that wraps up all of our questions.